clock bar. B, Q. How many transistors? Two transistors. One of them is NMOS, the other one is PMOS. Yes? Advantage over this one. This one will give you the polar air. You follow me or not? By the way, the two transistors, either both are what? Working, or both are what? Not working. Did you get it or not? No response. But this will require two phases of the clock. Which means what? I need to generate a clock. I need to use a clock and I need to invert it to get clock bar. Did you follow me or not? And there is a problem with that, which we'll talk about it when we get to the timing. Why? A clock, when it goes from 0 to 1, the clock bar is not going to go from what? 1 to 0 instantaneously. Did you get it or not? Because the clock has to go through an inverter, which means what? You need to take into account the propagation delay over the inverter. Did you get it or not? No response. Yes or no? Well, we'll talk about the timing next week. Let's get familiar, first of all, with the topologies. Okay, so this one will give me the what? The rail to rail. Yes? Is it still dynamic logic? Still dynamic logic, where the state is what? Did you get it? No response. Did you get it? It's still dynamic logic, but it solves just what? One problem. By the way, is the D open? You don't understand what do I mean by open? It means what? The input is not isolated from what? Noise. The input is not isolated. There is no buffering between them. I want you just to look at, I want you to look at what? I want you to look at this one. One second. Yeah, this one and this one. Do you see this one and do you see this one? Yes? What is the difference? Why did we add the inverter? Why did we add the inverter? We added the inverter at the output to what? Isolate the state of the what? This, you do understand this logic is what? One directional. You follow me or not? Which means what? If you do have a NOT gate, the output cannot go, the noise cannot go from where to where? From the output back to the what? Input. It can go from where to where? The input to the output. Did you get it? Mm-hmm. So what did I do here? I want you to tell me what difference between this one and the above one. What is the difference? Can you tell me what is the difference? One added a what? An inverter at where? At the output. And the other one added the inverter where? At the input. Yes? To buffer against what? Against noise. Did you get it or not? But in doing so, the latch became a what? An inverted latch. What does that mean? Can you tell me what does inverted latch mean?
Only Q bar.
Inverted latch means what? You have only access to what? Q bar, which is the opposite of what? The actual Q. So if you look at the Q bar and you see Q bar is equal to what? 1, that tells you the flip-flop or the latch is holding a what? A 0. Did you get it or not? This is called the what? Inverting latch. Clear? Clear? Okay. Now, I want to, before we get into this one device we have not studied yet, which we will study in a minute. This is called the what? The tri-state logic. What is tri-state? Tri-state logic has how many states? 3 states, either 0 or 1 or what? Z, which is open. But we'll get to that in just a second. I want to show you another one. And tell me what is this one going to do? Is this one sketched here? Let me see. No. So, let's see if you can help me. Clear? Let's see how this one works. Let's see. By the way, this is same as this one. I will explain that to you in just a second. Clear? Same, but this one uses what? Transmission gate and both. Let's call this one TG1. And let's call this one TG2. Okay, let's understand this diagram. When the clock is, by the way, is it dynamic logic or static? Huh? This is static logic, and you will see why in just a second. Okay, when the clock is high. Yes? What can you tell me about TG1? I'm still waiting. On. Yes? What can you tell me about TG2?
Off.
Yes? Yes?
Yeah.
Okay. Oh, I hate it when I drop the pen. Okay, help me. What happens? The D, where does the D go? This one is what? Open, which means what? I don't have any feedback.
Yes.
You follow me or not?
Yes.
Okay, what is this?
Q.
Q. What is this?
Q bar.
What is this?
Q.
Q. Which means the following. Listen to my question carefully. After how long will the what? Will the value of D shows up in the what? In the Q.
After the propagation.
By the way, remember, do we have access to this?
No.
No. Do we have access to this? No. We have access to what? To this one. Did you get it or not?
Yes.
No response. Yes or no? This is all one package. Did you get it?
Yes.
How long does it take?
The propagation delay of the
So
three.
for the what? For the value of D, two, transparently. Shows up in what? Q. After how long? I'm still waiting.
The
What is the delay? TG1 delay plus what? 2 inverter delay. Where is the 2 inverter? Can you show me where is the 2 inverter? This one and this one. Did you get it? No response. Did you get it?
Yeah.
Okay. When the clock is high, the latch when clock is high, the latch is in which mode? Is in transparent mode. You follow me on that? Yes or no? Yes. Okay. Now remember, by the way, there is a capacitor here, which means the level is on the what? On the capacitor. You might tell me, Professor, you just said static. We'll get to it in a minute. Did you get it or not? There is a capacitor here. Capacitor here. Okay. When the clock is low, when clock is low, TG1 is what?
off.
Off. TG2 is
On.
on. What do I have?
Feedback.
I have the feedback, the back-to-back feedback. Sorry, the back-to-back inverters. Did you follow me or not? And remember what I told you about the back-to-back inverter. The regeneration process, if you are in the state which is in the middle, it will eventually go either to what? What? Remember this diagram I showed you before? You forgot about this diagram? Do you remember this diagram?
Yes.
So if you are in here, yes, the regenerative process will push you either here or what? Here. Either to level 1 or level 0. Did you get it or not? Why? Because the feedback is going to provide you with what? With gain. Did you get it? No response. Did we get it? We talked about this earlier. Okay, so what will happen? Q bar. Let's assume D is 1. Let's assume D is 1. Yes? So when the clock is high, what is this one? 1. This one, 0. This one, 1. Are you following me or not? Now, let's assume the clock became what? 0. By the way, any other change in D, after the clock goes to 0, any changes in D will not matter. Why? Because TG1 is what? It's off. Did you get it or not? Okay, good. We'll talk about the timing next week. That's a big headache for sequential circuits. Okay, so now what do I have? If the clock went down, D is what? What was this one? 1. Yes? Look what happened. 1, 0, 1, 1, 0, 1, 1, 0, 1. Are you following me or not? That regenerative process, the back-to-back inverter, will result in what? Even if there is a degradation in the level here, with the amplification, it will pull back to what? To the stable states. Did you get it on that? This is a very widely used D flip-flop, this one. Did you get it? Okay. What is the problem with here? The problem with here, again, we go back to the same thing, which is what? Which is this clock and this clock bar. When this one is high, this is supposed to be what? Low. But since this one is generated from here, yes, there will always be some what? Delay between them, which means what? There is a possibility, what? What? There will be a conflict at this point. Why? Explain to me that conflict. I'm waiting for a response. Oh. I'm exhausted. Why? The previous Q could be what? 0, and the present D is what? 1. If both TGs are operating at the same time, why they are operating at the same time? Because there is a slight what? Delay between the what? Between the clock and the clock bar. Yes? Both TGs are going to be what? On at the same time. There is a conflict at the output of the TG1. Why? The TG1 is trying to pass what? A 1. But the feedback is feeding back a what? 0. Did you get it or not? Who should win? Who should win? No, don't tell me I don't care.
Well,
who should win? Who should win is the what? Is the D should win. Another TG1 should win. Did you get it or not? Which means what? We need to choose the what? The W over L carefully about what? The feedback and the what? The feed forward. The feed forward needs to be stronger than the what? The feedback. But we'll talk about the timing next week. Timing is a big headache with sequential circuit because whenever there is what? Misalignment, then there is a problem. Did you get it or not? Everything has to be what? Has to be aligned. Clear? Not sure, did you get it? Did you get it?
Yes.
Oh. What is, again, one more time. What is the delay between the D and the Q? The delay between the Q and the D is what? Delay of TG1, yes? Plus what? To inverter. You follow me or not? Whereas the delay between what? This Q and this Q involve what? Delay in here, delay in here, delay in here. I need to make the delay in here higher. So that this one passes a what? A 1 before this one circulate a what? A 0. You lost me here. Did you lose me? Yes, you did. Okay. Can we try it one more time? What does the propagation delay depend on? Do you remember the equation of TP? Yes? What was in the denominator? W over what?
L.
L in the denominator, which means what? If you make the W over L higher, the delay becomes what? Lower. Do you follow me or not?
Yes.
Yes or no?
Yes.
When there is contention, whoever wins that level will be the one that is used. Did you get it or not? We want the TG1 to win the race. This is called what? Clock race. We'll talk about that next week, the timing. Did you get it? This just to show you the flip-flop. Did you get the idea? Oh, good. This one is very popular. By the way, this one also could be implemented in a what? You see? In a master-slave configuration. Can you show me how? In a master-slave. This whole thing is a what? The master. Yes? Can you show me the slave? Exactly similar to this. Yes? But what? Flip this one. Flip this one. Did you lose me? Yes, you did. Help me. What is this? This is a clock. What would this one be? This one is what? Clock bar. This one? Yes? This one? Clock. What is this one? Huh? What is this? Short. Yeah, this is a clock. Why is it the whole thing? It's the clock. CLK. Yes? CLK. Bar. Did you get it?
Yes.
This is a what? Slave. This is the what? The master. Did you get it? And remember, by the way, in a master-slave configuration, it's edge-triggered, and what else? You don't have access to the what? To the master output, the state of the master. You only have access to the what? To the slave state. Did you get it? Yes or no?
Yeah.
This is one of the most popular ones. This one on this one by itself, and so on. Now I want to show you the tri-state. Where is the eraser? Here. Tri-state inverter. First of all, let's look at the symbol. Yes? No response. Yes? Enable bar or clock bar, doesn't matter. You follow me? Oh, good. Let's look at the circuit. clock bar, enable or clock, doesn't matter. By the way, this one also gives you what? Inverted logic. If you want Q, you need to add a what?
Inverter.
You need to add an inverter at the output to generate the Q. Is the diagram clear?
Yes.
Yes or no? Let's see how it works. Let's assume D equal to what? 1. Yes?
Yes.
Tell me what do we see? If the enable is high, if En is high, what can you tell me about this?
On.
On,
Off.
on, both of them are on. Why? Why is this one on?
Bar.
This is a PMOS, it's active what? Low. So if the enable is what? High, this one is what? Enable bar. By the way, is this CMOS logic?
No.
No, this is not CMOS logic. Why? In a CMOS logic, the inputs needs to be what? The same for the PUN and the what? PDF. Did you get it? It's not CMOS logic. Clear? Okay. So one more time. If let's call this one, let's name them M1, M2, M3, M4.
Just a quick question.
Huh?
What does M stand for?
Transistor, it's just terminology.
Okay.
No, the MOS.
Oh.
MOS MOSFET.
Okay,
Yes?
thank you.
No, but seriously, it's just that to call it Q1. You want to call it Q1? I can change it to Q1.
No, I was just curious.
No. It's just, I would assume it's MOS. Otherwise, I have no idea. In other words, I cannot answer your question. I'm sorry. I don't know, but I guess my guess is what MOS. Yes, but it's just terminology. Okay, En is high. What can you tell me? M3 is what? On. M2 is what? On. So what do we have left?
Inverter.
Remember, by the way, if it is on, what does it mean? It means that the transistors are acting as a what?
Switch.
Short. Did you get it or not? What do we have left?
Inverter.
We have an inverter, which means what? Q bar is equal to what?
D.
D. Did you get it or not?
Yes.
This is, by the way, one more time. It's a what? Inverted logic. Clear?
Yes.
So when you say Q bar equal to what? 1. Let's assume D is equal to 1. When you say Q bar equal to what? 1. What does that mean? What is being stored is a what? 0. Clear? It's an inverted logic. Did you get it?
Yes.
Okay, good. What if the enables if? So if D is what? If D is 1, that means what? Q bar is what?
0.
0. Yes?
Yes.
Which means what? Q is what? 1. Yes? If D is 0, what does that tell you? Help me. Q bar equal what?
1.
1, which means Q equal to what?
0.
0. Which means what? The Q and the D are the same. Did you get it?
Yes.
Yes or no?
Yes.
Okay, good. What if the enable is low?
Q bar equals Z.
What is M3?
Off.
Off. Everybody see why it is off? Low means what? 0. M3 is off. M2? Huh?
Off.
Off. Why?
Q PMOS.
This is a PMOS. You follow me or not?
Yes.
So if En is what? Low, it means what? En bar is what? High. That's a PMOS. Which means what? It's cut off. Yes? What is the output? What's Q bar?
Z.
Why?
No connection.
Why Z?
No connection up
So,
or
so
down.
nothing there. At this point is a floating.
What does it
Did you
mean
get
to
it?
say Z though?
Could you repeat that again?
What does it mean to say like?
High impedance. When you see something open, what does it mean? What high impedance? What does high impedance mean? It means that it behaves as a what? Open circuit. What it means actually is what? Is that we are not sure what is the state. We are not sure what is the state because we don't know what was the previous state. You follow me or not? So we just call it high impedance because it's what? It's open. Clear? Open circuit means what? Means impedance is what? Infinity. Yes? Yes? Do you understand why they call it tri-state?
Yes.
Everybody, what are the tri-state?
0, 1.
0, 1, and high Z. Okay, now questions before I run out of time. Question. Can I do what? Can I do this?
Yes. Yes.
By the way, do you understand the changes?
Yes.
In the previous one, the enable was here, the enable bar here, enable here, and these were connected together. Now I changed the enable to what? M4 and M1, but these are connect them to what? To D. Clear?
Clear.
Let's see what happens. Let's see what happens. If the enable, let's assume D is equal to what? 1. By the way, I'm still going to take it from here. Clear? Okay. If the enable is what? What did we start with? If the enable is high. Yes?
Yes.
What can you tell me about this?
On.
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 On. So this one is on. This one is on. Yes? Okay. What would this one be?
Q.
Assume D is what? Assume D is what? High.
Yeah.
Let's assume D is high. What can you tell me about this?
On.
On.
Off.
Off. What is this?
Low.
Low. Which means what? This one is going to be 0. You follow me or not?
Yes.
Okay. Let's assume D is what? Low. Yes?
Yes.
And the enable is still what?
High.
High. On.
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 Off.
Off. Did you get it?
Yes.
What is the output?
High.
High. Yes? So my question to you is what? I want you to look at the diagram. Where is the diagram? Oh, I did not put the diagram? I forgot. I'm sorry. I did not put the. No, I did. I did. Second page. Second page. Do you see the top one? Do you see the top one?
Yeah.
Okay. By the way, another name for it is what? C squared. Moss. Yes?
Yes.
Yes? What is this C squared came from? Complementary CMOS. Complementary, double complementary. Follow me on that? They call it C square MOS. Yes?
This is a double CMOS.
Okay, I run out of time. Can you tell me why is this one not recommended? This one is not recommended. This one is okay. Second one is not. Which means what? This is no good. Why? Because there will be what? If this one is on, there will always be what? Charge sharing. Remember we saw this problem earlier?
Yeah.
Yes or no? Or you forgot? So even though this one is not working, but there will be a what? Charge sharing this one here. In other words, the charge here will what? Some of it will go to the capacitor here. Did you get it or not?
Yes.
Did we discuss this earlier?
Yeah.
Yes or no? This one is suffer. But if you go this one, the previous one, no, has no effect. Why? Because the D is on the what? On the top. Yeah.
So it works, but not as good.
That's good. Of course, it works, but it's not as good as what? As the previous one. Clear? Could not finish it this, I always say I will finish, I could not. Okay, we will finish it next week. Did you get it? Oh, can you check it again for me, please? The game.